objectives for this are naming, identification of appropriate apparatus used in different measurements. You can come across measurements regarding the key measurements regarding time. Then you can come across measurements regarding temperature, then mass, volume, and many more measuring apparatuses, lab apparatuses being used. The next objective of this is regarding suggesting suitable apparatus for what purpose? For collection of gases and then measuring rate of reactions. The next content is methods of purification and analysis, in which we will talk about different separating techniques like filtration, then crystallization, distillation, decantation, and fractional distillation. So this will be discussed in second part of this chapter. Then we will talk about chromatography as well. In addition to this, we will also talk about chromatography, the details regarding chromatography. In addition to this, there is melting point and boiling point deductions and their effect on purity. We'll talk about in this second part. Let's move to the third part now. Third part of this chapter is identification of oils and gases. You have different identification tests to learn in this chapter for paper 4. One thing important is that these techniques, the techniques of this chapter, you can come across questions related to them in especially paper 1 and paper 4. So let's start with the part 1 now, experimental design. In experimental design, we will discuss different measurements of different physical properties. There are actually 4 important physical properties in chemistry. The first one is mass. The second one is volume. Then we have time, and then we have temperature. Okay, let's start with mass. Mass is the matter that is present in a body. Matter that is present in a body is mass. The SI units for this purpose are kilogram. You may also use other units like grams, tons, etc. Milligram. You can come across different units while solving different problems. And you should also be knowing one of the major conversion. 1 kilogram is equal to 1000 grams. Let's talk about the apparatus that can be used for measuring mass in lab. You can use different balances, for example, beam balance. For example, you can use electronic balance. You might have seen it in your kitchen as well. A small balance is there which gives you a digital reading. Then we may also have a traditional weighing balance as well that is enclosed with the glass bars around it to prevent any sort of effect of air on your measurements. Let's talk about now volume. Volume is actually defined as the space occupied by any substance. So let's talk about its units. Now the units which are usually used for volume are the most commonly used for chemistry is dm cube. So you may come across cm cube, m cube, meter cube, and then liter as well. These are the different units which are used. And we have one important conversion related regarding volume is 1 dm cube is equals to 1000 cm cube, and it is equals to 1 liter. We have various different apparatus being used in lab for measuring volume. They vary according to their accuracy, according to their capacity. So we have beakers. They are less accurate and they can be used for any random mixing, volumes taking, etc., but not for accurate readings. You may find different measurements for beakers, 50 cm cube, you may find 100, 150, 250, and so on. So then we have measuring cylinders. They have more accuracy than beakers, and once again you may have different measuring cylinders starting from 10, 50, 100, so on. The important thing to know about measuring cylinder is that they can give you an accuracy up to 1.0 cm cube. So if there is a chance of error for 1.0 cm cube, but accuracy is very much as compared to beakers. Next we have category of other like we may have volumetric flasks. They are also different, labeled differently, 50, 100, 200, and they are used for titration purposes usually. Then we have burette and pipette. If the accuracy is there, burette can give you a measurement for 25 cm cube, and it gives you a slightly increased efficiency in terms of accuracy. And then we have pipette. Pipette is more accurate. It can give you total volume that it can have is 50 cm cube, and it can give you an accuracy till 0.1 cm cube. So it is much more accurate, and it is also used for titration experiments. Okay. Then we have gas syringes as well. Gas syringe, if you have ever seen a normal syringe, it looks like the same. On one side it has for getting in gas in, and we have a plunger on the other side. There is a plunger on the other side, and it is marked. All the volume measuring apparatuses are marked, graduated. This is plunger, and this is barrel. Barrel is pushed behind when the gas enters. Barrel is pushed behind, and then the plunger is moved in and out. We have two types of gas syringes, small and big ones. The small ones, they are used for measuring liquids usually, and the large ones, they are used for measuring gas volumes in terms of accuracy. Let's talk about next physical property, that is time. Time, there is units for measuring time are seconds and minutes. You can also talk about in hours, and the devices are stopwatch, that may be analog stopwatch with a dial in between, and there is a switch on and switch off button. It is a switch button, and we may also have digital stopwatch. Digital stopwatch may have a screen in which a digital number is there, and once again switches there to measure. For accurate reaction measurements, we need a stopwatch to measure time. Then we have temperature. We can come across in different reactions. We have to measure temperature. For example, endothermic, exothermic reactions we will talk about later on. So for temperature measurements, the units are usually degree Celsius, degree Fahrenheit, but the most common is Kelvin. You need to convert both of them to Kelvin to be used in different calculations. And for measuring temperature, we have once again digital thermometers are there. And we also have manual thermometers, which may once again clinical as well as lab thermometers. So they can give you relative readings. Okay, now let's talk, these are about the measurements. Let's talk about now the next is actually how to take readings, important. Pause करना है. पॉज कर दे.
पॉज ना करें, हाँ इसको धीरे से.
अब कट कैसे होगा?
वो मैं कर लूँगा. स्विच है कोई मुझे?
Yep, but I don't know ये वहाँ तक पहुँचेगा कि नहीं?
पहुँच जाएगा. इधर नहीं कोई स्विच
होगा. ये डोर बंद कर दे. Now the next important thing is about how to take readings. Taking readings. You should be able to read these apparatus very carefully, because you can be asked, as you are asked in paper 4, to fill in certain tables for unit readings for solving titration questions. So one thing important first is looking at the meniscus. Meniscus is actually the level of a liquid. You might have seen that some liquids, they are bending outwards, and for some liquids if you have seen the readings, they are bending downwards. It is the specific ability of colorless liquids that they bend outward. So in such a case, what is the exact reading you have to note is this one, which is touching this top. And for the colored ones, you have to note down this reading. So it matters a lot that you should be able to note down the exact readings for colored liquid and for colorless liquids. For example, if this is the ending point is 20, but this is 21, 20, this is 20.2 reading, and over here if it is, this is 20 and then it is 19.9, which is the exact reading. So you should be very much careful. All these are graduated. This is burette, for example, so you should be very much careful. One thing you also need to be careful is you should be also following that in which way the numbers, the graduated numbers on the cylinder or on the burette, they are increasing or they are decreasing. You should follow them, and then you should be coming up with your final reading. So it is important. For noting down the readings, important thing for noting down the readings on burette, you should be very much careful that first you should note the initial reading from where you are going to start the reaction, and then you should also note the final reading where final volume is ending. So let's talk about now. Next is collection of methods for the collection of gases. The next topic is method for the collection of gases. There are different methods which are followed for collecting gases, but these methods actually depends on the nature of the gas. Nature of the gas in terms of two properties that we have to look for: density of a gas with respect to air. Some gases are denser than air, some gases are lighter than air. And we also have to look for their solubility in water. Before we opt for a method for selecting a gas, a particular gas, nitrogen, oxygen, carbon dioxide, we have to look into their two properties. One is density of a gas with respect to air, and the other is solubility in water. So we have up to now, there are four methods which are usually followed. Let me list them down. One is collecting gases on water, displacement of water. Then we have the other method, that is by downward delivery method. Then we have another method, that is upward delivery method. And furthermore, we have by using gas range. Now let's talk about which method is followed for which purpose. This is displacement of water. It is followed for the gases which are insoluble in water, because if the gas is soluble in water, you cannot opt this method. And examples being hydrogen, oxygen, and carbon dioxide. Although carbon dioxide is sparingly soluble, but it can be collected with this method. Let's have a look on its separator setup. There is a delivery tube, and you have a water bath filled with water and delivery tube, and this is a jar inverted. It is also filled with water, and you can have this gas collected over here by displacement on water. This is water filled with water. Because the gases are insoluble, so it doesn't make any difference. Delivery tube. This is gas jar. Okay, let's talk about now the other downward delivery method. It is for those gases which are denser than air and they are soluble in water. So means soluble in water means you cannot use this method if a gas is soluble in water. So for example being chlorine. Let's talk about its apparatus setting. You have a delivery tube and it is simply entering in a gas jar, and the gas jar is closed. So you have delivery tube and gas jar. Okay. Next is the upward delivery. It is opposite. The gases are lighter than air. And once again they are soluble in water. For example, ammonia. They are collected by upward delivery method. So you have a delivery tube that is entering in an inverted jar. This is gas jar and this is delivery tube. You should be able to mention each apparatus that is being used in your diagram. Let's talk about gas range. They are used, what is the purpose behind? For accurate volume measurements. This is used, and usually for rate of reactions. Such reactions in which rate of reaction depends on the volume of a gas produced. And in this we just have a flask that is connected with directly with the gas syringe, and the volume is noted from here. So this is how the gas syringe is being used for collection of the gas. Now, how to collect a dry sample of a gas, collecting or drying of a gas. Next, we should be able to how to collect dry sample of a gas or drying of a gas. Here, once again, we can use any drying agent. For this purpose, we can pass our gas through drying agent before final collection. Now, this drying agent depends on gas. Drying agent, for example, if we have an acidic gas to be collected, for an acidic gas, for example, CO2, drying agent will be sulfuric acid, concentrated sulfuric acid, and then finally the gas is collected. Similarly, if we have an alkaline gas, for example, ammonia, the drying agent will be alkaline in nature, for example, calcium oxide, that is also alkaline, and finally our gas is collected. The third is for neutral gases. Drying agent is drying agent is calcium chloride, and then our samples. It is because if you will use the drying agent of the opposite nature, they will react and you won't be able to collect any gas. But if you use the drying agent of the same nature, then you would be able to collect the gas and there will be no reaction taking place. For sulfuric acid, usually we have this mechanism. Gas is in from one delivery tube and there is a flask. The gas is in and there is sulfuric acid at the base and this gas is out. This is concentrated sulfuric acid is there. For alkaline, we have gas in and we have in such medium the drying agent is filled here. That can be calcium oxide, gas in and gas out. You can also use another apparatus like gas is in and you have here the container in which your calcium oxide is fixed and here gas out is there. You can also use this. Similarly, for calcium chloride as well, you can use the same apparatus. You can also add calcium chloride over here or over here because they are in solid forms, so you can use both of them. This is about collecting dry sample. Now there is a problem question for you, a practice question. For example, there is a container. You are given with this experimental setup in which this is gas jar and we have gas coming in from here, delivery tube, gas in. And we have gas out coming from here and this is sent to a jar in which Y is there. And over here you have this tube entering in. This is X. And this is Y. Now you have to suggest what is X and Y. What is X and Y? So you are given options. Options here are A, concentrated H2SO4 and ammonia. Option B, concentrated sulfuric acid and CO2. Option C, water and CO2. Option D, water and ammonia. You can choose your answer and you can give your feedback in comments with reasons. So I will be looking for it, and of course the answers I would like to have from you. So this is all about the part 1 of this, and hopefully now you will also, for the next part we will be discussing separating techniques, purification techniques, and the effect of purity on the substance melting point and boiling point. So for now, this is all.